Today we'll discuss the distributive property and how we can use the distributive property to model real-life situations mathematically. Our first example focuses on three friends going to a baseball game, where each ticket cost $20 and where all three friends decided to buy a baseball hat for $15 each. So we'll take a look first at the statement 3 times 20 plus 15 and discuss what that's doing to represent our story. Well, our 3 represents the three friends. The 20 represents the cost per ticket. And the 15 represents the cost per baseball hat. And it's very important as we are looking at situations and stories and word puzzles that we understand how we can represent each part of the story. The next expression looks at the story a little differently, where we see 3 times 20 plus the 3 times 15. Well, the 3 times 20, if you think about that, that's 3 people, $20 per ticket. So that 3 times 20 represents the cost for all 3 tickets. And then the 3 times 15, again, we have 3 people each buying a baseball hat. So this would represent the cost for all 3 baseball hats. So let's take a look at how we would evaluate that expression, how we would simplify it by doing all the operations that we can do. With order of operations, we're going to do the multiplication first, and then we'll add those products together. So if we look at the 3 times 20, remember that was the cost for 3 tickets. Well, $20 3 times is going to be $60. 15 times 3, the cost for 3 hats, will be $45. So when we put those two numbers together, we get a sum of $105. Now that's the amount that the 3 friends spent all together, the cost of the tickets and the cost of the hats combined. To describe the distributive property in words, we would think about the cases where when we need to multiply a sum by a number. Now a sum is an addition. So that means we're taking 2 numbers that we'd like to add together and then multiplying them by the same factor. In order to do that, we could add those together and then multiply. But sometimes it's easier for us to multiply each addend or each part that we're adding together by the number outside of the parentheses. So in the example, you see that I have 2 times 7 plus 4. Well, if you think about 7 plus 4, that's 11. And 11 times 2 would be 22. But if I look at it in a different way, you'll see that I could do 2 times 7, which is 14, and 2 times 4, which is 8. And when I add those 2 products together, I get the same result. I get that 22 that I would get if I did 2 times 11. So the distributive property just allows us to see situations from a different perspective. Okay, let's take a look at the example on this screen. You're being asked to use the distributive property to show 49 plus 21. Now, if we were just adding those, we could put those together and we know we would get 70. But the distributive property is going to ask us to see things a little differently. So to do that, I'm going to think about common factors. And if I look at 49 and 21, I know that I have a common factor of 7. I can divide both of those numbers by 7 and get a whole number quotient in the end. So I'm going to think about 49, and I know that 49 is 7 times 7. So I have one 7 on the outside of the parentheses. The second 7 goes inside. I'm going to add to that my thinking about 21, and I know that 21 is 7 times 3. So I have the 7 already on the outside. I'll put the 3 in the parentheses and close that up. So if you think about this, if we distribute this out again, we know that 7 times 7 is 49. And we know that 7 times 3 is 21. So that's a way for us to check to make sure we have set up the distributive property statement correctly. All right, let's take a look at the situation from Sprinkle Me Silly Cupcakes. Sprinkle Me Silly makes 40 chocolate cupcakes and 64 vanilla cupcakes. They want to make up boxes of cupcakes so that the boxes are identical, and they want to make as many boxes as possible. So let's use the distributive property to show them how they could set up these boxes. So since we want as many boxes as possible, that says to us, oh, we should be thinking about the greatest common factor of 40 and 64. So if I think about my greatest common factor for 40 and 64, I know that my greatest common factor is 8. I can divide 40 and 64 by 8 and get a whole number quotient. So I'm going to put that 8 right here. So I know that I can multiply something by 8 for each of these numbers. I know that 8 times 5 gives me 40, so I'm going to put that 5 right here. And I know that 8 times 8 gives me 64, so I'll put that 8 right here. And I can check my work by going back and saying 8 times 5, that is 40. And 8 times 8 is 64, and that matches up with the numbers we originally started with in the story, so this statement checks out. Now this time, Sprinkle Me Silly makes 63 chocolate cupcakes and 72 vanilla cupcakes, and again, they want to make up identical boxes and want to have as many boxes as possible. So again, that's a GCF situation. If I look at 63 and 72, I know I have a greatest common factor of 9. So I have to think about what I can multiply 9 by to get 63, and that would be 7. And so I'll put the 7 right here. And I know 9 times 8 gives me 72, so I'll put that 8 here. Can double check. 9 times 7 is 63. 9 times 8 is 72. So I'm back to my original number, so that checks out. Now the situation is represented with the distributive property. Now instead of saying 63 chocolate cupcakes and 72 vanilla cupcakes in the story, this number in parentheses is really the combination of cupcakes in the box. In each box. So in each box we have 7 chocolate cupcakes, we have 8 vanilla cupcakes, and this number on the outside is telling us how many boxes we have made. How many identical boxes we can put together with 63 chocolate and 72 vanilla cupcakes. All right, another nice use for the distributive property is that it can really help us with our multiplication of fractions. So I look at this this statement. I'm asked to find 9 times 4 1/3 mentally using the distributive property. So I want you to write down these steps with me, even though the goal is for this to be a mental process for you. But let's write this down in your notes so you can think about the steps that you're going to use in your head. So we're going to start by thinking about 9 times 4 1/3 as 9 times the sum of 4 plus 1/3, which is really what mixed numbers are. They're the addition of a whole number plus a fraction. We're then going to use the distributive property to multiply 9 by both of those parts. So we can do 9 times 4, and then we can do 9 times 1/3. Well, that becomes mental math for us because we know 9 times 4 is 36. And if you think of 9 times 1/3 instead as 1/3 of 9, remember of is the magic word, well, that becomes mental too. So we know that we have 36 plus 3. And then we can add that together in our head to get 39. So by using the distributive property, this multiplication puzzle becomes something that we can do without a calculator and without necessarily writing it down on paper. Let me get this out of the way here. All right, well, let's just put it there. It's your turn. Pause the video and try to do 5 times 2 3/5 and 2 times 3 6/10. You see that decimal over there. By using the distributive property. All right, if you look at 5 times 2 3/5, we know we can rewrite that as 5 times 2 plus 3/5. And then you see that we can distribute the multiplication, and we can get 5 times 2 out of that, and 5 times 3/5. The 5 times 2 would be 10. And then the 5 times 3/5 would be 3, because you think about that 5 over 1. And then the 5s would simplify out to 1 each. And so that gives us 13. Again, it makes that multiplication a little more easy to manage mentally. In the second example, if we break this down, we have 2 times 3 plus 6/10. Now think about money with this. This is like $3.60. And I know that if I have $3 twice, I'm going to have $6. And if I have 60 cents twice, that's going to be $1.20. Okay, so when I add that up, I get the $7.20, or 7 2/10. Please make sure you have all the examples in your notes, all the explanations that go along with it, particularly this example up above on this screen, and bring your notes into class and we'll have some discussions. Thanks.